So first, thanks for your attendance. This is an introduction about Taura Laboratory. I will mainly talk about the research life and work we are undertaking in Taura Lab. So first is a self-introduction about me. I'm Lila, a foreigner student coming from China. From this semester, I entered the third year of a doctoral course. And I started in China before coming to Japan and enjoyed all of our research life as a graduate school student in Japan. Of course, I have lots of hobbies, such as classic animations and their series. I played soccer throughout the period before entering the graduate school. I also like mahjong. And here are some interests that are not so common, such as myths, especially Indian one, that's my favorite. And I think I have lots of minority interest. Here is the basic situation of our lab. So currently we have 40 students, consist of 10 graduate students and 4 undergraduates. To my experience, I think we regularly have 4 undergraduate students join our lab each year. Of course, there are several foreigner students. And you must be curious about the research life. So I think we always have several student members come to the lab in the past, but most of us start to work remotely from this pandemic age. The main point is that we don't have something like core time. Many people prefer this as it is flexible for managing the work-life balance. But when there is a meeting, you should attend if not bothered by your personal affairs. And I believe in-person conversation is very helpful for discussion. Our meeting regularly starts from 9:30 a.m., but sometimes will be rescheduled according to professor's convenience. Actually, there are 2 kinds of meetings, but I think it's not much different comparing to other labs. So in the first one, you should report what you have done in every 2 weeks. It can be as simple as something like this. Of course, you can share your experience if you met some technical issues or have some experiment results. And in the second one, we rotate students to give a presentation about paper you ever read. It can be either a conference paper or a journal one if you think it is valuable. Then try to articulate it so that you can get some experience from the presentation. Of course, you are encouraged to talk in English as we have several foreigner students. But I believe no one will think it disturbing if you want to use Japanese. So actually, there are some differences before and during the pandemic age. Before that, we regularly hold a progress report and 1 paper reading every week. It's on-site and we gather in a room. But now we hold 2 to 3 short progress reports and 1 paper reading every week. All of them are online, but we need to stay for another 30 minutes after meeting so that you can talk to others. And we also tried 3 offline meetings this April. And as far as I know, I think many labs use Zoom for online discussion, but we gather in Gather. Then let me talk about the researches in Taura Lab, especially mine. So although there are various of research topics our members are undertaking, but the main topic is high performance computing. Most of us are interested in parallel techniques. The research goals are mainly about, for example, applying parallel techniques to various of research fields, such as machine learning and other scientific computations, or developing libraries and tools to support parallel programming. And of course, we also have some other research topics like model checking and machine learning. The most important thing is that if you have your own research ideas, no one will follow you. And I believe teachers will give you valuable advice. So I will use my research as one of the research examples. Its eventual goal is supporting fast data extraction for various kinds of data formats. So as you know, there are many ways of data storage. Database is a popular one. Structured data is through indexing, and media data is categorized as unstructured data. The median of them is called semi-structured data, such as XML, JSON, and HTML. That are quite popular in data exchange, as you know. But one of the disadvantages is that this kind of data should be parsed before using. Someone may think it quite tricky as you have to use language-specific parser. So when you have a JSON text, you must use a JSON-specific parser. And in another day, you get a XML dataset, and you have to use XML parser. Especially when you are a parser developer, that means lots of programming efforts. Gratefully, there is a tool called parser generator. Programmers are unnecessary to always make a new parser when encountering a new data source. This tool can automatically generate parsers through a specification called a grammar. And some people prefer this as writing a grammar is much more simple than making a parser. And our goal is supporting parallelization in this kind of tool. Actually, parallelization is a very powerful weapon in accelerating various of scientific computation. So let's consider a simple data extraction task and see why parallelization is powerful. So in this task, we use Yelp's review. This data set contains lots of reviews for business, like scoring of stars and the category of this business. The data extraction task is called rating distribution that analyzes the frequency of each unique stars number. And we expect some simple results like this. So let's see the performance difference using some tools and how parallelization is powerful. The last one, PLEX, is a tool developed by our lab. So I will show it directly. So when you want to extract some data from a JSON text, you may use some library of Python, like here's a library called Panda. And you will write some codes for data extraction, like this. So actually, this is the part for data extraction. Because pandas provide lots of interface and you can use it very simple. So you may run T like this because we need to calculate the execution time. So we use an identifier. And this computation will take about half a minute. So let's wait for the results become available. So it print out the computation time. It is 27 seconds. And including the I/O performance is about 29 seconds. It's quite slow, right? And another tool is called Rapid JSON. So it's a JSON specific parser. If you want to use it, you need to write some code like this. So this is the part for data extraction. And here we print out the results. So as we have binaries, so let's run it directly. It is much faster than using the pandas of Python. So the computation took about 2.8 seconds and 3.4 seconds in total. And let's see how PLEX is faster through parallelization. So as I said, PLEX is a generator, and you must to write something called a grammar like this. This grammar is specific for JSON. And when you have a different language, you need to write a different grammar. So the code is look like this. You need to write a function to tell how to extract data. So we want to extract the start field, and it's followed by a colon token. And we use some built-in functions and finally print out the result. So let's see the performance when using one thread. It is not so faster, and I think it is slightly slower than repetition. So it took about 3.9 seconds in computation and 5.5 seconds in total. Then let's double the number of threads. So it should be slightly faster. So the computation time is reduced, and now it is about 2.4 seconds. Let's still continue double the number of available threads. It's much more faster, right? And let's continue. So you may see it's quite fast now, and we can continue double the number of available threads. So now you can, I think you have already understand why we say parallelization is a powerful weapon in accelerating computation. And you may think it's quite tricky, as you have to write some grammars for data extraction. So here is another, but when you have another language, it's quite simple because you only need to write such a grammar. So now we have another language called faster, and you write this grammar, then use PLEX. And when you have another language called sen, you can simply write such a grammar, and PLEX will generate the parallel tokenizer for you. So here's the last page of this introduction. And again, thanks for your attendance. And I will be very grateful if you feel curious about the researches in Taura Laboratory.